Thank you all very much, and welcome to the Central Coast Sustainable Business Showcase for our second talk of the day. First talk went really well. We had Paul from the council talking to us how we can save a fortune and spending money on infrastructure by just managing our water resources more effectively. But now we've got Chris Gibey and his beautiful assistant Philip, who will be talking to us about graphene and what they're doing with graphene. It's been the wonder material for as long as sort of I've been interested in tech startups. But these guys have actually managed to make some commercially valuable products, but I'll let them talk about that. So a little bit about Chris. Chris started off in a band. So all of those have got kids who do music at school. Then it's not necessarily a bad idea so long as you move on to other and better things. Chris has moved on from the band, did publishing, set up TV shopping network, and is a serial entrepreneur. To list all the things he's done is ridiculous. But where I met Chris, he was commercialising technology out of Wollongong University. And so he did a lot of work with advanced materials, and graphene being one of them. And this is a spin-off out of that research that they're doing. And at the moment, they're looking for businesses to help roll this out around the world, demonstration products and things. So rather than me bang on, I will give the wand of power to Chris, who will tell you what he's doing.
Thanks, Bruce. Thank you very much. Great to be here. I've been promising myself to come up and visit Bruce in his operation for quite a while, so it's great that he kind of pushed me into making the drive. And thank you all too. I hope that what I'm going to share with you is interesting. So, how do we get, what's happening? Do I need to switch this on? Maybe. There we go. Well, Bruce has talked about this graphene as a super material. It really is an amazing material. The guys who discovered it got the Nobel Prize early on in 2010 to 2012, around about then. And it, as a material, it's a carbon allotrope. It's made of carbon, and it's the first 2D material. So anyway, we can talk about that in more detail if necessary, but I think the main thing about any material, all these superlatives are great, but what's it going to do? And that was one of the hard things in graphene. So they said early on, when I first started my experience, as Bruce said, when I was at University of Wollongong, and they said, graphene can do almost anything except escape from the lab. So here's the company that I founded together with, as Bruce said, my beautiful assistant Phil, who's the head of R&D, and he is a materials scientist of some repute, or so he tells me. We focused on how to generate data out of graphene and to use graphene as a sensing material. Part of the reason that we did this was because I'm extremely interested in the commercial aspects of things, both because then you know you're solving problems for people, and also you get to make money. And it means if you make money, you can get investors, and the whole cycle continues. So we focused on data in part because one of my buddies who made a lot of money in the mining industry said to me, well, Chris, if you've got a 2D material and like graphene, you should be able to cover the entire planet with 1.5 kilos of graphene. How the hell are we going to make money? And he said, you've got to get volume. And then we started talking, Phil and I started talking about where was the application that would mean that you had to produce massive amounts and deliver a result, and that was sensing. So we then started focusing on buildings and construction. And there were two things that you're about to see that bit, which I'll talk about in a moment. So we focused on two things, sensing floors and leak detection. And earlier on we heard a bit about the value of preservation of water and managing water. Well, what you're going to see in a moment, I hope, if Phil gets his act together, you're going to see a proof of concept of leak location that can go into cross-laminated timbers in buildings. We've done a deal with Stora Enso, global company based in Finland, to productize this for their cross-laminated timbers. The first commercial installation of that's going to take place in the Melbourne CBD in this building in a couple of weeks, as soon as the workers can go back on site, which is pretty exciting. I think that leak location, leak detection in buildings in construction is just a massive opportunity. So the other area is sensing floors, and we've spent a lot of time working on developing a way to get data out of flooring. And I'm going to take you into the more specific application in just a second. This has been a huge amount of effort from a group of people both here. Our main operations are in Geelong. We've got a small factory there producing materials, and that's where the materials science research takes place. And we built a subsidiary company in Finland to develop a team of signals processing engineers, because they have very good signals processing over there. And so it's a combination of those two real skills that have taken us to where we're going. And, just before I move on, it's Phil's turn to present his demo of leak location. There you go, Phil.
Thank you, Chris. We'll give you a very quick demo of one of the technologies we're using. Over here, I'll show you a little black panel, piece of wood with some graphene coatings on it. This thing is a little bit temperamental because of the Wi-Fi network. So this is no electrical connection to it at the moment. It's using Wi-Fi. If it works as planned, if I spray some water on it, the system should tell me that it got wet. There's a slight delay as the water absorbs in. You can see a color change. And depending upon the amount of water on the system, it'll go a different color. More water, darker, and eventually it'll actually set off an alert, eventually. I have to tune this every time, unfortunately, so it doesn't look like it's going to give me... Oh, there we go. There's often a sound response as well. I've turned it off, but it's on the laptop. So it'll send an alert to wherever you are wirelessly and say there is a problem at a certain place. And it'll tell you the magnitude of the problem. And that's the important bit as well. The same technology can be used in a lot of different locations. This is for buildings, so this is a coating on wood. Same concept can be used anywhere in construction. That's the quick demo. I can explain more later. We've got plenty of time. Come and talk to me. Actually, we usually thank the guys who are not here. They're the guys who built it. The fact it works is great. I'll tell you what, take that as
Thanks, Phil. I think that's bloody incredible, really. And the applications are just huge. But the other part of this is you can do it for virtually, the cost is so low that it's possible to do it anywhere. I mean, it really is very, very inexpensive. So, but Phil will take your questions. Let me take you a little bit further down the journey. So we also identified a really big unmet consumer need, which is of personal interest to me because I'm getting on in years, and that's how to figure out how to be able to provide really in-depth monitoring for aged people who choose to live at home. And this is the subject of a long-term research project that we've started and initiated at Swinburne University, and we've got a bunch of pretty interesting partners involved too. It's just in the process right now of cranking up. I can talk about that to anybody who's interested later. But I wanted to, more particular, because I know Bruce and how he thinks, and he likes to get shit done really quick. So, COVID response commercialization case study. So we started developing this smart floor. This is a building in Augsburg in Germany where we installed a prototype smart floor. And we've had a lot of success in terms of just the slow development of understanding what sort of sensing needs to be done to satisfy a customer in an office building. Of course, now the office building market has gone a little bit off the rails, and because of COVID. And so I started saying to the guys, you know, we've got to get a product to market. We've got to do something that can result in sales now. We've got these nice development projects with big companies, but we need something now. Because what the problem is, we need to give people confidence that they can go back into public spaces. And how could we repurpose what we're doing in fixed floors in a way that would have relevance now that we could manufacture quickly as well? So we then started thinking about how you could build basically a set of mats, non-fixed flooring. And then we came up with the idea of putting lights into this and to create a system that would have a traffic light system to be able to advise people where they should go. So in fact, a behavioral management system. And then we said, and by the way, all this was at the first couple of days in August was when this conversation took place. End of July, beginning of August. So then we said, can we get a product to market this year? Could we do it by November? And you know, I pose these questions and everybody looks at me and goes, you bloody idiot. That's not possible. We'll get it into the market next July. Of course, I say, well, that's no good, because next July, who knows what's going to be in place. We've got to do this now. We've got to be relevant now. Make the money now. So, traffic light system for people management. And Phil worked like crazy to get a patent filed. Well done, Phil. And now it's moving into something slightly more sophisticated, and this is essentially the basic idea. You know, these red lights and green lights that tell people where to stand. And then we went, well, we've got to get some data out of this that'll be valuable. So we can do people counting, and we can do analytics, and we can do alerts. And then we thought, well, we should be able to do customizable skins, different kinds of carpet on the surface. And we should be able to manage the queues and alert the people who run the building as to how fast or slow a queue's moving. A whole load of things we started to think about. And then we came up with a brand name and registered the trademark. And then we ran in the third week of August, because guys went like crazy to do this. Third week of August, I called up the guy from the Geelong Advertiser, the business editor, and said to him, hey, Dave, if we do a demo at a local coffee shop, would it be of interest for you to cover it? And he said, well, what is it? And I explained it to him. I said, look, there's a photo op because of the lights. And he said, sure, let's do it. And so we got a little bit of visibility in the local paper, which is always good because, you know, it just gets everybody excited. And as my wife says to me, you like to make sure that the phone rings. So it's true. I like to get people excited and involved. So we then, what's happening? Port to the screen, sorry. Whoops. Go back. Right. So that's the concept. So there's a combination here of LED lights and our graphene-based pads that go into these pixels that monitor pressure and tell you whether somebody's walking, tell you how many people are walking on the pad, whether there is a child or an adult, a whole load of data. So I then talked to one of my friends who's a professor at Deakin, and very bright lady, and I said, Tuba, would you be prepared to do some focus group research for us? Because I want to make sure that we really are developing this product the way it needs to be. So she said, sure. We put together a Zoom conference call with a bunch of invited people, about a dozen or so people. Huge amount of insights. I'm not suggesting you read any of that, but just a huge amount of insights as to the sort of things that people thought would be valuable. And then we started talking, because you've got to have a customer in order to make sure that you're real. I started talking to the Geelong City Council and talked to the head of Smart Cities there, who was part of the focus group. And because of that, and the fact that our factory is down there, we're locals there, and they're very supportive. So he said, this is going to be ideal to help people go back into venues and make people feel confident. And so this is the stuff that he said, second week of September. This will help people go back into swimming pools, libraries, museums. And we said, can we do another installation so that we can get real insights from the people who are going to be using this, people who work for you? So we agreed to do that and to get an MOU in place. And then separately, I was introduced by one of my directors to the advisor to the Minister of Sport for South Australia. I had a very interesting discussion with him. And he started to talk to me about the problems that he sees. And they were quite different to what I had thought and totally different to what came out of the focus group. Very interesting insights, but what I realized was the opportunity for this is just huge, absolutely huge. And it's, in some respects, the reverse of what I'd thought. I thought if you can help people queue up on their way into a stadium for a sporting fixture, that's going to be really a tremendous thing and mean that there's less crowds, etc. He said to me, no, it's not about that. That's good. But it's really about when they leave, because they all leave at the same time. And that's the problem. And he said to me, and the stadium that he was most concerned about in Adelaide, he said, 15,000 people is our break even, 25,000 people is our target. Every person after 15,000, that money's straight to the bottom line. And until we have a solution, we can't get people in. And I thought, holy shit, that's great. Now we've got something to focus on. And in fact, just before I came in this morning, I was having a discussion with a guy who's very connected in sports, and he's now going to be involved in helping us build relationships with clubs all over the world and get product out. So this is this is where we're going to do the first test installation in Geelong, outside the Cardinia Aquatic Centre. And yesterday afternoon, I met again with Tuba on a Zoom call to make sure that we get clarity on what the analytics need to be that go into the product. So just going beyond the raw data and into what the value is for the people. And this is kind of the ongoing issue: is how do you build the design to optimize for the customer, to make it plug and play, and also to reduce the amount of service that's required in the field. And by the way, with a product like this, there's a huge risk of breakage, damage to the product, so it's going to take a while to get this squared away. Nevertheless, where we're going is we are moving on to the commercial prototype. Then this is going to happen in the next two to 3 weeks. We will do the installation in Geelong at the Aquatic Centre. There'll be a demonstration at the Adelaide Convention Centre. We're going to get purchase orders in place as a result. We're going to modify our design, get the minimum viable product units out, and over the next 3 weeks, I expect to close a manufacturing and distribution partnership to get this product to manufacture at scale. and that my expectation is we'll close a deal with the largest flooring company in Australia to do that. We've been in discussions with them forever, so this is now something that's quite real. My target, you may think I'm totally bloody wacko, but my target is we're going to have purchase orders for 1,000 units by November the 30th. That will generate around about $1 million, perhaps a little bit more. So that's my target, generate $1 million of gross revenues by Christmas, probable delivery time sometime in January. Next year, generate $7 to $10 million of revenues. I think we'll do much more. And we'll take this product to market internationally. And within the next 2 years, this company will be built to be $100 million of revenues, and I'm going to sell it for a lot more. That's my goal. Now, I've done this shit before, and I fully intend to do it again. I'm kind of at the point in my life where I don't want to have to keep on doing it, though. So I'd like to make this one really work big time so that the parent company, Imagine, can be a very serious business. So we're going to need some working capital to do all that, so we're spinning this out as a new entity. It's going to be called OnQ Proprietary Limited. There'll be a sister company in the US, OnQ Inc. Still got to work out a lot of the details on this, but I'm going to raise $750K right now with a rolling close. That'll help us deliver the first $500,000 of orders. We got visibility on that already. I mean, no paper, but I'm starting to get those purchase orders now in place. One of them, by the way, is going to be Swinburne University, because they're going to incorporate this device into the testing stations that they're putting throughout the campus to make sure that people sanitize, etc., have their temperature checked before they go into the campus when they reopen. So this is, that alone is going to be more than 50 units. The investment that we're going to do is through what's called a SAFE document, which is like a convertible note. So that will mean that the notes convert into equity when we do a full capital raising. That's it, and that's the investment amount. Now, I suspect that most of the people here are probably more interested in the leak location than they are in this, but I'm sure there will be people interested in this too. So I want to bring Phil back, please, so that you can talk a little bit more about how we do the actual data from the materials, and a little bit about graphene, etc. And then we'll do the Q&A, and off you go.
Right, thanks, Chris. So the technology itself you saw demonstrated. Chris has talked a bit about how it can be used. It's quite simple, is that graphene is just carbon, but it responds very strongly to certain stimuli. Like you compress it, you apply pressure, or you put water on it. And it's electrically conductive, so it means that there are no wires now, because the coating is also the wire. So that's why it works in very large areas. The advantage of the technology is that the competing technology is widgets. You stick little devices everywhere. And you can do that, and people do it. It's expensive and painful, requires servicing. There's a lot of problems associated with it. The joy of particular areas like construction and mining is that these are very large areas we're talking about now. And it's impractical to do that. So the joy of the technology is it's also cheap. You know, people will talk about graphene as the wonder material, and it is. It's also overhyped, and people will charge a vast amount of money for it if they can. But they're trying to sell a material. We sell data. So we want to make the material free if we can. And graphene itself should not be expensive. It comes from graphite. So we can already do this. We have a factory in Geelong for about $50 a kilo. It'll be $5. So graphene's cheap. It's the same price as plastic. So anyone who tells you graphene is expensive and a wonder material, they're trying to sell you something. What we're trying to sell you is data. So the joy of the technology is that you can use it in a lot of different environments where they have a problem that can't be solved in other ways. That's the key thing here. Large area surfaces, large areas like floors, roofs, walls. So depending on what your interest is, if you're trying to do queue management now, it's getting big. These devices can be done other ways. But this is a small version of our floor. If you try and do the same thing in this environment, you just can't do it in a way which is cost effective. I think the cheapest other technology out there is about $100 a square metre for a floor. That's quite expensive. Not infeasible, but it's too expensive for any normal person to use. So that's where we came from and said, how do we actually solve the problem of getting sensing everywhere? And it's black, so the one thing I do have to point out, we can't do everything because it's black. Everything you get is going to have a black coating on it. There are transparent graphenes, but that's not us. You don't pay $5 a kilo for that. On top of that, then you need to get signal out. Because if you've got a system which is covering an area this big, normally what you do is you stick lots and lots of wires. That's an electrician's job. Because our system is the wires, what we can do is attach from the edge. But how do you know where something's happening? This is a large conductive surface. No one's ever done this before. So we had a material which allowed us to develop some techniques for working out where something is now happening. That's actually where the real value in our company is. The signal processing, it's electronics, it's analog signal processing, it's old-fashioned type of stuff. You then turn it into digital signals that you can analyze in the context. Is it a floor? Is it a roof? Is it a wall? What does it mean? What people want is the mean. What does it mean? So we've got a bunch of guys in Finland who do almost all the electronics. They develop that. They're all ex-Nokia and Microsoft and people like that. They're some of the smartest people on the planet. They just don't want to leave Finland, so they're cheap. I'm a New Zealander, so I also say the same thing about New Zealanders. We often stay at home. So you get good people cheap because they stay there. They like the environment. I like the environment over here quite a lot too. So that's the basis of it. After that, you come to the very specific applications. And each of them has a different requirement. So that coating over there is an acrylic coating. It's effectively paint. What do you need to do now? How do you modify that, for example, for a building made out of composite laminate timber, which is what we're working with. Chris referred to Store Enso. These are now 7-story buildings made out of wood. And we need to put this everywhere we can where there's a leak. The incorporation now into their manufacturing process is the important bit. So we adapt what we do to what they need to make the product. And that's where a lot of our expertise has been applied as well. It's make the right graphene at the right price so that someone can use it in their process. We don't tell them to change what they do. That's our major goal. We don't walk in and say, well, you can use us if you change everything, because the answer is always no. That's one of the hardest things to do in terms of the material science. Make the product adapt to someone else's process. Deliver it in a way they can just tip it into their process. That's the ideal. It's never quite that easy. So conceptually, that's how the technology works. I mean, the details of graphene and everything else I can talk about ad infinitum. I actually don't think it's important. I'm a material scientist, but I don't think it's important. It works. The fact you can get it modified and delivered means that there are different ways of solving the problem. And one of the things we talk about, I'm not quite as old as Chris, but I'm older than I look, no one's quite as old as Chris, but there's a scene from The Graduate where they're talking about the future and plastic. The future is plastic. That's 40 years old, not even, possibly. And if you put that in context, graphene is 10 years old-ish. The future may or may not be graphene, but the problem is very similar. It's not about graphene, it's about what do you do with it. Nobody cares about plastic. People care about what plastic does. Graphene's exactly the same. A lot of people talk about graphene as being a wonder material and they'll just sell it to you, but you don't know what to do with it when you get it. So we really are a solutions-based company, and we're pretty narrow in what we do. We have to be. We're still a small company. I think there's 15 people globally. So it is about understanding very specific problems and solving them. So we want to hear about people's problems. And as like Chris said, we thought we had a great idea for solving queuing problems, and then someone flipped it on its head. Still the same solution. You just apply it slightly differently. Thank you, and we'll be rattling around, so feel free to ask lots of questions.